On July 1, 2025, a discovery was made that would fundamentally challenge everything we thought we knew about our place in the universe. What started as a routine night of asteroid hunting in the Chilean desert has become the most controversial astronomical discovery in human history, and the more data we collect, the more questions arise that NASA seems reluctant to answer publicly. I'm about to walk you through the discovery of 3I Atlas, an object that has left some of the world's most respected astrophysicists questioning whether we're looking at a natural comet or something far more extraordinary. By the end of this series, you'll understand why this discovery has sparked heated debates in classified briefings, why certain observational data remains mysteriously unreleased, and why some researchers believe we may be witnessing humanity's first encounter with technology from beyond our solar system. But first, let me tell you exactly what happened on that night in July when everything changed. The Atlas telescope system in Rio Hurtado, Chile, operates like a cosmic security camera, scanning the skies for potentially hazardous asteroids that could threaten Earth. It's part of NASA's planetary defense network, designed to give us early warning of incoming space rocks. The system has discovered thousands of asteroids, and July 1st seemed like just another routine night of observations, until it wasn't. At precisely 3:47 a.m. local time, the automated detection algorithms flagged something unusual. The object was moving too fast to be a typical asteroid. Its trajectory was hyperbolic, meaning it wasn't gravitationally bound to our sun. This was immediately significant because it marked only the third time in human history that we'd detected a visitor from interstellar space passing through our solar system. The first interstellar visitor, 1I Oumuamua, had been discovered in 2017, followed by 2I Borisov in 2019. Both objects had sparked scientific interest, but 3I Atlas would prove to be different in ways that no one anticipated. The initial observations showed something that should have been impossible. When astronomers calculate the size of distant objects, they use brightness measurements combined with assumptions about surface reflectivity. For 3I Atlas, these calculations kept producing the same troubling result. The object appeared to be roughly 20 kilometers in diameter, making it absolutely massive for an interstellar visitor. To put this in perspective, that's larger than Manhattan Island, twice the size of the asteroid that ended the dinosaurs 66 million years ago. But here's where things get statistically disturbing. According to our understanding of how much rocky material exists in interstellar space, we should encounter an object this large only once every 10,000 years. We've been systematically searching for interstellar objects for barely a decade. The odds of finding something this rare so early in our search are approximately 1 in 1,000. It's like predicting that a specific rare bird will fly past your window once every millennium, and then ting it on spot day, your first of bird watching. Avi Loeb, Harvard's longest-serving chair of astronomy, immediately recognized the statistical problem. In his analysis, he pointed out that we should have discovered roughly 100,000 smaller interstellar objects before ever finding something as massive as 3I Atlas. Yet we'd only found 2 previous visitors, both much smaller than this newcomer. The size anomaly was just the beginning. As more observatories turned their attention to 3I Atlas, a pattern of unusual characteristics began to emerge that would challenge every assumption about how interstellar objects should behave. The trajectory analysis revealed the first major red flag. Unlike typical interstellar visitors that can arrive from any random direction, 3I Atlas approached our solar system aligned within just 5 degrees of the ecliptic plane. This is the flat disk where all our planets orbit. The statistical probability of this alignment occurring by random chance is approximately 0.2%, or about 1 in 500. But the trajectory gets even more suspicious when you examine where this object was heading. 3I Atlas wasn't just passing through our solar system randomly. Its path was precisely calculated to provide close encounters with 3 major planets: Venus, Mars, and Jupiter. The combined probability of these 3 planetary approaches occurring by chance, given a random trajectory and timing, is less than 0.005%, or roughly 1 in 20,000. If you were an engineer designing a spacecraft to conduct reconnaissance of our solar system's major bodies, you couldn't plot a more efficient course. The trajectory maximizes scientific observation opportunities while minimizing energy expenditure and detection time. It's the signature of intelligent mission planning rather than random cosmic wandering. The timing of these encounters raised additional concerns. 3I Atlas would pass Venus at optimal distance for atmospheric studies, approach Mars close enough for detailed surface observations, and swing by Jupiter at the perfect range for studying its complex moon system while using the gas giant's gravity to modify its outbound trajectory. Perhaps most disturbing was the approach vector itself. 3I Atlas had arrived from the direction of Sagittarius, directly toward the galactic center, where the crowding of background stars would have made early detection nearly impossible. It remained effectively invisible until reaching Jupiter's orbit, giving humanity only a few months to study it before it would disappear behind the Sun. This concealment wasn't accidental. Analysis of the visibility conditions revealed that 3I Atlas had chosen the approach path that would minimize its detection window while maximizing its observation time once discovered. If you wanted to study a planetary system while avoiding early detection, this is exactly how you would plan your approach. The physical observations from space telescopes added even more anomalies to the growing list. The James Webb Space Telescope's analysis revealed that 3I Atlas has one of the highest carbon dioxide to water ratios ever recorded in any comet. Most comets in our solar system are primarily water ice, with traces of other compounds. 3I Atlas is the opposite, dominated by carbon dioxide with minimal water content. The chemical composition suggested either an extremely unusual formation environment or possibly an artificial coating designed for thermal protection during interstellar travel. Carbon dioxide ice has different sublimation properties than water ice, making it an interesting choice for thermal management systems on long-duration space missions. Visual observations from Hubble revealed another impossible feature. The dust trail from 3I Atlas was pointing toward the Sun rather than away from it, creating what astronomers call an anti-tail. This configuration violates basic physics. Solar radiation pressure should always push comet material away from the Sun, not toward it. Maintaining such a structure would require active energy expenditure and real-time force management at levels suggesting sophisticated technological systems. The anti-tail phenomenon isn't just unusual, it's aerodynamically and gravitationally impossible under natural conditions. Creating and maintaining this configuration would require technology capable of counteracting solar radiation pressure, gravitational influences, and electromagnetic effects simultaneously while preserving structural integrity across millions of cubic kilometers of space. Amateur astronomers worldwide confirmed these professional observations using much smaller telescopes, making it impossible for authorities to suppress or classify the unusual findings. The democratization of astronomical observation meant that official attempts to control information about 3I Atlas were increasingly futile. As October approached and 3I Atlas continued its precisely planned journey through our solar system, each new observation added to a growing picture of an object that didn't quite fit any natural explanation. The statistical improbabilities were stacking up beyond the realm of coincidence. The Mars encounter on October 3rd would provide the first real test of what 3I Atlas was truly capable of. And the results of that flyby would either put the alien technology theories to rest, or provide the most compelling evidence yet that humanity was being visited by intelligence from beyond our solar system. The Mars flyby represented something unprecedented in human history. Never before had multiple spacecraft from different nations simultaneously coordinated to observe what might be humanity's first encounter with extraterrestrial technology. As 3I Atlas approached the Red Planet on October 3rd, an international network of robotic observers prepared to document whatever this mysterious visitor might reveal about its true nature. NASA's Mars Reconnaissance Orbiter was repositioned specifically for this moment. The spacecraft's high-rise camera, normally used for photographing Martian surface features with incredible detail, was reconfigured to track 3I Atlas during its closest approach. The resulting imagery would provide resolution down to 30 kilometers per pixel, offering the clearest view yet of whatever technology or natural processes space agencies Mars. The European Express and Impossible Behavior were driving this object. ExoMars Trace Gas Orbiter joined the observation campaign, their instruments calibrated to capture spectroscopic data about 3I Atlas's emissions and surface composition. Even China's Tianwen-1 mission contributed to what became the most comprehensive surveillance operation ever directed at a single astronomical object. But here's what makes this story even more intriguing. Despite the international coordination and the historical significance of the moment, the data from these Mars observations has never been publicly released. NASA and ESA have remained mysteriously silent about what their spacecraft documented during those crucial hours when 3I Atlas passed within 29 million kilometers of Mars. The only glimpse the public has received came from an unexpected source. Astrophotographer Simeon Schmaus, analyzing publicly available images from NASA's Perseverance rover on the Martian surface, managed to stack multiple exposures and detected what he described as a faint smudge at the precise location where 3I Atlas should have appeared in the Martian sky. This raises uncomfortable questions about information management. Why would space agencies immediately share routine Mars geology findings, but withhold data from humanity's most significant astronomical discovery? What did those high-resolution images reveal that required such careful handling? The silence becomes even more suspicious. Consider the when-you timing. The Mars flyby occurred during observation, the optimal what researchers call window, when close 3I Atlas was enough for detailed study, but still far enough from the Sun to avoid electromagnetic interference. If authorities wanted to conclusively prove this was just an unusual comet, releasing clear imagery showing natural comet behavior would have ended the controversy immediately. Instead, the information blackout has only intensified speculation about what the Mars orbiters actually observed. Some researchers suggest the data might show structural modifications to 3I Atlas that occurred during its approach, changes that would be impossible to explain through natural processes. The mass analysis conducted during this period revealed perhaps the most disturbing anomaly yet. Using trajectory data from 227 observatories worldwide, researchers calculated that 3I Atlas must weigh at least 33 billion tons to explain its resistance to the rocket-like forces created by its massive outgassing. This calculation creates an impossible equation. The James Webb Space Telescope had measured 3I Atlas losing approximately 150 kilograms of material every second, ejected at velocities of 440 meters per second. According to Newton's laws of motion, this mass loss should have been pushing the object significantly off course. But 3I Atlas continued moving as if nothing was happening, following its trajectory with clockwork precision. To remain unaffected by forces that should have been altering its path, 3I Atlas would need to possess density approaching that found in neutron star material. We're talking about matter so compressed that a teaspoon would weigh as much as a mountain. But neutron star material cannot exist under the temperature and pressure conditions of interplanetary space. The implications are staggering. Either 3I Atlas is constructed from exotic matter states that human science has not yet discovered, or it possesses technology capable of actively compensating for the forces trying to push it off course. Both possibilities challenge our fundamental understanding of physics and engineering. Dr. Maria Gonzalez, a celestial mechanics expert at the European Space Agency who had initially been skeptical of artificial theories, found herself forced to confront mathematics that defied conventional explanation. If an object is losing mass at the observed rate through non-symmetrical ejection patterns, basic conservation of momentum requires detectable trajectory changes. The absence of such changes suggests either our understanding of physics is fundamentally incomplete or we're observing technology that can violate conservation laws. The 33 billion-ton mass estimate places 3I Atlas in a category thousands of times more massive than the previous interstellar visitors. This represents what statisticians call a major anomaly, an observation so far outside expected parameters that it demands explanation beyond simple chance. Consider the mathematical progression. 1I Oumuamua was roughly football field-sized. 2I Borisov was similar in scale. Both followed the expected distribution, where smaller objects are exponentially more common than larger ones. Then suddenly we discover 3I Atlas, potentially 100,000 times more massive than its predecessors. It's like finding pebbles on a beach for years and then discovering a mountain. The size distribution in space follows predictable patterns. There should be billions of small interstellar rocks for every large one. We should have catalogued tens of thousands of Oumuamua-sized objects before ever encountering something as massive as 3I Atlas. Yet we'd found exactly 2 small visitors before this giant appeared. This statistical impossibility has forced researchers to consider explanations that venture far beyond conventional astronomy. Either interstellar space contains far more large objects than our models predict, or 3I Atlas represents something fundamentally different from natural space debris. The chemical analysis added another layer to the mystery. Unlike typical comets that are mostly water ice, 3I Atlas showed an 8:1 ratio of carbon dioxide to water. This composition is among the most extreme ever recorded, suggesting formation conditions unlike anything in our solar system. Carbon dioxide ice behaves very differently from water ice. It sublimates at different temperatures, reflects light differently, and provides different thermal properties. If you were engineering a probe to survive millions of years of interstellar travel, carbon dioxide ice would be an interesting choice for thermal regulation and surface protection. The object's age estimates add yet another impossible element to the puzzle. Trajectory analysis suggests 3I Atlas may be 7 billion years old, making it older than our entire solar system. This ancient wanderer has been drifting through the galaxy since before Earth existed, carrying secrets from the early universe. But objects don't maintain structural integrity across such vast timescales without some form of maintenance or self-repair capability. Natural comets break apart, wear down, and fragment over much shorter periods. The fact that 3I Atlas has maintained its massive size and apparent structural sophistication across billions of years suggests engineering that approaches immortality from a technical perspective. As 3I Atlas continued its approach toward the Sun throughout October, each new observation added to the growing list of characteristics that challenged natural explanations. The object was demonstrating capabilities that seemed to operate outside known physical constraints, while following a trajectory that suggested deliberate intelligence rather than random cosmic motion. The approaching solar conjunction would soon hide 3I Atlas behind the Sun for 6 crucial weeks, creating the perfect operational window for any activities its controllers might prefer to conduct without human observation. When it emerged in December, would it still be the same mysterious visitor that had entered our solar system, or would it reveal modifications that finally answered the question of what humanity was really dealing with? The timing of 3I Atlas's approach to solar conjunction couldn't have been more perfectly orchestrated if it had been planned by mission strategists. October 29th marked the date when this enigmatic visitor would reach perihelion, its closest point to the Sun, and simultaneously disappear from all Earth-based observation for 6 weeks. This wasn't just an inconvenient astronomical event. It represented what orbital mechanics experts call the optimal window for conducting covert operations. When an object reaches perihelion, it experiences the strongest gravitational forces from the Sun. Any propulsion system activated at this moment would be amplified by what's known as the Oberth effect, allowing maximum trajectory changes with minimum energy expenditure. Dr. Sarah Mitchell, NASA's Director of Mission Planning, found herself studying 3I Atlas's path with a mixture of professional admiration and growing unease. The timing represented mission planning at a level that exceeded human capabilities. If you wanted to use solar gravity to modify your trajectory while remaining hidden from observation, this would be the perfect moment to do it. The solar conjunction would create complete electromagnetic interference, making it impossible for any Earth-based telescope to observe what 3I Atlas might be doing during those crucial weeks. Radio telescopes would be overwhelmed by solar noise. Space-based instruments would be blinded by the Sun's glare. For 6 weeks, humanity would be completely blind to the activities of the most significant object ever detected in our solar system. But the strategic advantages of this timing extend beyond simple concealment. Analysis of 3I Atlas's approach vector revealed that its arrival at perihelion would occur precisely when Earth was positioned on the opposite side of the Sun. This wasn't just hidden from view, it was hidden from the planet with the most advanced space surveillance capabilities at the exact moment when those capabilities would be most needed. Dr. Robert Kim at Stanford, who had been analyzing 3I Atlas using game theory and strategic planning models, calculated the probability of such perfect timing occurring by chance. His analysis suggested odds so remote that coincidence became virtually impossible to defend. The positioning demonstrated operational security awareness that exceeded most military reconnaissance missions. Intelligence agencies worldwide had quietly begun treating this timeline as a potential threat scenario rather than an astronomical curiosity. The possibility that an unknown intelligence might conduct operations in our solar system while remaining completely undetected represented a security challenge unlike anything human civilization had ever faced. The 6-week blackout period would also provide the perfect window for what researchers had begun calling the mothership scenario. If 3I Atlas intended to deploy smaller reconnaissance probes, the solar conjunction offered ideal cover for such operations. Any objects released during this period would remain undetectable until they chose to reveal themselves, potentially months later. Amateur radio operators around the world had been monitoring electromagnetic emissions from 3I Atlas throughout its approach. In the weeks leading up to solar conjunction, several operators reported detecting structured patterns that seemed to increase in complexity as the deadline approached. The signals were too weak for definitive analysis, but their timing suggested that 3I Atlas might be preparing for activities that would occur during its hidden passage. Marcus Rodriguez, whose Arizona observatory had become a coordination center for citizen science efforts, organized a global network of observers to maintain some level of surveillance during the blackout. Thousands of amateur astronomers coordinated their efforts, monitoring the sun's corona for any unusual activity that might indicate 3I Atlas's presence or operations. The network Rodriguez established represented an unprecedented mobilization of civilian surveillance assets. For the first time in history, ordinary citizens were actively participating in what amounted to an alien contact detection protocol. The democratization of this search effort created capabilities that often exceeded official institutional responses. But even the most sophisticated amateur equipment faced fundamental limitations when dealing with solar interference. The best estimates suggested that only the strongest electromagnetic emissions would be detectable during the conjunction period, leaving the vast majority of potential activities completely unobservable. Professional astronomers found themselves in the frustrating position of losing visual contact with the most important object in human history at the precise moment when understanding its behavior became most crucial. Dr. Jennifer Walsh at the Space Telescope Science Institute described the approaching blackout as the longest blind spot in surveillance history. The psychological impact of having a specific timeline for potential alien activity had transformed human society in measurable ways. Stock markets experienced unprecedented volatility as investors attempted to price scenarios ranging from technological revolution to existential catastrophe. Religious communities organized continuous prayer vigils while secular institutions prepared for possibilities that challenged every assumption about humanity's place in the universe. Social media platforms struggled to manage the explosion of speculation, conspiracy theories, and genuine scientific analysis that the approaching deadline generated. The hashtag Tracking3I Atlas accumulated over 50 million posts as people worldwide shared theories, fears, and preparations for what might occur during the hidden period. Educational institutions found themselves attempting to prepare students for a future that might be fundamentally different from anything in human experience. The uncertainty surrounding 3I Atlas had forced educators to focus on adaptability and critical thinking rather than specific knowledge that might become obsolete overnight. International cooperation reached levels that would have been impossible during previous periods of global tension. China's National Space Administration shared surveillance data with Western agencies for the first time in decades. Russian space assets coordinated with NATO systems. The magnitude of potential alien contact had created temporary unity that transcended terrestrial political divisions. But this cooperation was complicated by the absence of established protocols for managing such scenarios. No international frameworks existed for coordinating responses to alien contact, and the urgency of the approaching conjunction had prevented development of comprehensive cooperation agreements. The European Space Agency took extraordinary measures, repositioning several deep space monitoring satellites in attempts to maintain some observational capability during the blackout. The maneuvers required burning precious fuel reserves and would significantly shorten the operational lifespans of affected spacecraft, but the potential intelligence value was considered worth the sacrifice. Russia's Roscosmos made similar preparations, though their efforts remained largely classified. Leaked communications suggested particular concern about the possibility that 3I Atlas might emerge from solar passage with altered trajectory parameters, confirming beyond doubt that the object was under intelligent control. As October 29th approached, the global community braced for what many researchers were calling humanity's first experience with forced ignorance about events that might determine their species' future. The solar blackout represented more than just an observational gap. It had become a test of human civilization's ability to maintain rational decision-making while confronting the ultimate unknown. The approaching conjunction deadline had also revealed vulnerabilities in human psychological resilience when facing cosmic uncertainty. Mental health professionals reported significant increases in anxiety-related inquiries, particularly from people obsessed with calculating approach vectors and deployment timelines for potential alien probes. Support networks formed for individuals struggling with what psychologists termed contact anxiety, the fear that humanity was unprepared for whatever might emerge from the hidden period. These communities evolved beyond simple crisis management into ongoing forums for processing the broader implications of living in a universe that clearly contained intelligence far exceeding human capabilities. The December emergence timeline had become seared into global consciousness. When 3I Atlas reappeared from behind the Sun in early December, humanity would finally learn what activities had been conducted during those crucial weeks of invisibility. The object that emerged might be identical to the one that entered, or it might reveal modifications that would fundamentally alter human understanding of what they were dealing with. But regardless of what 3I Atlas might accomplish during its hidden passage, the experience of collectively anticipating such possibilities had already transformed human civilization in ways that would persist long after the immediate crisis passed. The approaching solar conjunction had forced humanity to confront questions about intelligence, technology, and cosmic contact that previous generations could only imagine. As the final days before conjunction ticked away, telescopes around the world captured their last images of 3I Atlas before it vanished into the sun's overwhelming glare. These final observations would provide the baseline for comparison when the object eventually reappeared, potentially revealing whether humanity's mysterious visitor had remained unchanged or had used its hidden weeks to complete whatever mission had brought it across the vast distances of interstellar space to our solar system. The countdown to solar conjunction had become more than an astronomical event. It represented humanity's first deliberate preparation for potential alien contact, complete with international coordination, civilian surveillance networks, and contingency planning for scenarios that challenged every assumption about technological capability and cosmic intelligence. Whether 3I Atlas emerged as friend, foe, or something entirely beyond human comprehension, the approaching deadline had already marked a turning point in human history that would reshape civilization's understanding of its place in the universe. The blackout began exactly as predicted. On October 29, 2025, 3I Atlas disappeared behind the sun's blazing disk, taking with it any hope of understanding what humanity might truly be dealing with. For 6 weeks, the most sophisticated telescope networks on Earth would be reduced to helpless speculation, while an object of potentially alien origin conducted unknown operations just 93 million miles away, hidden by our own star. But the silence from official channels during this period would prove more telling than any observation could have been. While amateur astronomers maintained their vigil and citizen scientists shared every anomalous reading they could detect, government agencies and major space organizations seemed to retreat into an information vacuum that felt increasingly deliberate. Dr. Elena Vasquez, whose original trajectory analysis had sparked the global controversy, found herself caught between mounting pressure from colleagues demanding she distance herself from increasingly dramatic theories, and her own scientific integrity that refused to ignore the mathematical evidence. The data didn't care about career implications or institutional comfort. The numbers told a story that conventional astronomy couldn't explain. During the blackout weeks, several events occurred that would later be pieced together into a narrative far more complex than simple astronomical observation. Amateur radio operators reported subtle but persistent electromagnetic anomalies that seemed to pulse in mathematical sequences. The patterns were too weak and intermittent for definitive analysis, but their timing corresponded precisely with theoretical models of what alien communication attempts might look like. More disturbing were the reports from deep space monitoring networks that had been quietly repurposed from military surveillance to cosmic observation. classified systems designed to track satellite threats began detecting faint but structured signals that appeared to originate from the solar vicinity. The transmissions showed characteristics that some analysts interpreted as systematic scanning patterns, as if something was methodically examining Earth's electromagnetic signature. These observations remained buried in classified briefings until investigative journalists began uncovering fragments of the larger picture. Leaked documents revealed that intelligence agencies worldwide had activated protocols originally developed for managing unprecedented technological threats. Communication networks were placed on enhanced monitoring status, while underground command centers that hadn't been fully operational since the Cold War suddenly returned to active readiness. The corporate response during this period proved equally revealing. Technology companies experienced massive stock fluctuations based on speculation about potential knowledge transfer opportunities. Defense contractors saw similar volatility as analysts debated the relevance of conventional weapons against technology that appeared to manipulate fundamental forces. The market movement suggested that informed investors were pricing in scenarios far beyond simple scientific curiosity. Religious communities struggled with theological implications that traditional doctrine had never anticipated. The Vatican issued carefully worded statements about divine authority, transcending any technological capabilities that alien intelligence might possess. Other organizations developed entirely new frameworks for addressing the spiritual implications of encountering minds that might approach godlike technological mastery. But perhaps most significantly, the blackout period coincided with a series of technical failures and communication disruptions that seemed too coordinated to be entirely coincidental. Satellite networks experienced unexplained interference patterns. Deep space telescopes suffered equipment malfunctions that prevented observation of the solar vicinity. Radio astronomy facilities reported systematic noise that overwhelmed their ability to detect weak signals from the direction of the sun. The pattern of failures suggested either unprecedented bad luck or deliberate interference from a source capable of disrupting human technology on a global scale. When equipment designed to monitor the cosmos suddenly develops problems during humanity's most important cosmic observation period, the timing raises uncomfortable questions about causation versus coincidence. Amateur observers, working with equipment immune to whatever was affecting major installations, continued documenting anomalies that official sources seemed unable or unwilling to acknowledge. Their distributed network provided resilience against systematic interference while democratizing access to information that institutional channels were failing to provide. Marcus Rodriguez and his global amateur network detected what they described as structured light emissions from the solar corona during the conjunction period. The observations were at the absolute limit of their equipment capabilities, but multiple independent confirmations suggested that something was indeed active in the solar vicinity during the weeks when 3I Atlas should have been completely hidden. The amateur data painted a picture of coordinated activity rather than passive transit. Time-lapse photography from observers worldwide showed consistent patterns in solar electromagnetic behavior that corresponded to theoretical models of large-scale engineering operations. If 3I Atlas was conducting construction, repair, or deployment activities, the solar environment would provide perfect camouflage while offering unlimited energy resources. International cooperation during the blackout revealed both unprecedented unity and disturbing limitations. While nations shared surveillance data with historic transparency, the absence of established protocols for managing potential alien contact created coordination challenges that highlighted humanity's unpreparedness for cosmic-scale events. Emergency sessions at the United Nations addressed scenarios that no diplomatic framework had ever considered. How do you negotiate with intelligence that operates on million-year timelines? What constitutes appropriate response to technology that approaches the theoretical limits of physical law? The discussions revealed gaps in human institutional capacity that extended far beyond simple military preparedness. Educational systems worldwide adapted curricula to address possibilities that traditional knowledge frameworks couldn't accommodate. Students found themselves studying adaptive thinking and cognitive flexibility rather than specific technical skills that might become obsolete overnight. The 3I Atlas crisis had forced education to focus on preparing minds for unprecedented change rather than mastering established information. Mental health professionals documented the psychological impact of cosmic uncertainty on human populations. The experience of collectively waiting for potential alien contact while remaining completely ignorant of actual developments created stress patterns that had never been studied in clinical settings. Support networks evolved to help people process existential questions about humanity's place in a universe that clearly contained intelligence far exceeding their own capabilities. The blackout weeks had ended, but the mystery had only deepened. When 3I Atlas finally emerged from behind the sun in early December, the object that reappeared would either validate humanity's hopes for a natural explanation or confirm their worst fears about what was really visiting our solar system. Harvard astrophysicist Avi Loeb ran the numbers, and what he discovered should have been impossible. Given the limited amount of rocky material floating around in interstellar space, we should have detected roughly 100,000 small interstellar objects before ever finding one as massive as 3I Atlas. We'd only found 2. The statistical probability of discovering something this large this early in our search is like winning the lottery while being struck by lightning. Twice. But size was just the beginning of the anomalies. When the James Webb Space Telescope turned its incredible instruments toward 3I Atlas, what it detected defied every model we have for cometary composition. The chemical signature was wrong. Completely wrong. Typical comets are mostly water ice with traces of other compounds mixed in. It's a recipe we've seen thousands of times in our own solar system, but 3I Atlas showed a carbon dioxide to water ice ratio of 8:1, 8 parts carbon dioxide to 1 part water. This is among the highest ratios ever recorded for any comet anywhere. Most objects we've studied have much more water than carbon dioxide. 3I Atlas is essentially the opposite of what we'd expect. Think about that for a moment. This object traveled for potentially millions of years through the void of interstellar space, somehow maintaining a chemical composition that suggests it formed under conditions completely unlike anything in our solar system. The implications are staggering, but the chemical anomalies were just getting started. When astronomers used the Very Large Telescope to analyze the gases being emitted from 3I Atlas, they detected something that made them question their instruments: nickel, lots of nickel. But here's what made it truly bizarre. There was no iron. In every comet we've ever studied, nickel and iron appear together in roughly equal amounts. It's one of the most consistent patterns in space science. You find nickel, you find iron, period. But 3I Atlas was pumping out nickel emissions while showing no detectable iron signature whatsoever. This combination is virtually unknown in natural objects, but is exactly what you'd find in industrially manufactured alloys. Let that sink in for a moment. We're looking at an object that's displaying the chemical signature of industrial manufacturing while hurtling through space at speeds that would vaporize any known material on impact. The water emissions presented another puzzle that has scientists scratching their heads. When NASA's Neil Gehrels Swift Space Telescope observed 3I Atlas, it detected massive amounts of water vapor being released from the object's surface. We're talking about a staggering rate of water production that far exceeds what should be possible for a comet at that distance from the Sun. Comets typically become active when they get close enough to the Sun for solar radiation to start melting their icy surfaces. But 3I Atlas was blasting out water when it was still beyond the orbit of Jupiter, at distances where most comets remain frozen solid and inactive. Something was driving this water production that had nothing to do with solar heating. The mystery deepened when astronomers realized that despite losing massive amounts of material through these water emissions, 3I Atlas showed no signs of the trajectory changes that should have resulted from this outgassing. When a comet ejects material, it acts like a tiny rocket engine, slightly altering the object's path through space. But 3I Atlas continued moving as if nothing was happening, as if the laws of physics didn't apply to it. The mass calculations that emerged from this observation were mind-boggling. For an object to resist the momentum changes that should result from such massive material ejection, it would need to weigh approximately 33 billion tons. 33 billion tons. That's roughly equivalent to a small moon compressed into an object that might fit inside a major metropolitan area. The density requirements for such mass in such a small volume approach those found in neutron stars, where matter is compressed so tightly that a teaspoon would weigh as much as a mountain. But neutron star material cannot exist under the temperature and pressure conditions found in normal space. The physics simply doesn't work. Then came the observations that made even skeptical scientists take notice. The Hubble Space Telescope captured images showing what astronomers call an anti-tail structure. Instead of material being pushed away from the Sun in the typical comet tail formation, 3I Atlas appeared to have material pointing toward the Sun, creating what looked like headlights rather than a tail. This configuration violates basic physics. Solar radiation pressure should push material away from the Sun, not toward it. For 3I Atlas to maintain this impossible structure, it would need to be actively controlling and directing its material emissions using forces and technologies we don't understand. The orbital mechanics presented their own set of impossibilities. 3I Atlas didn't just randomly wander into our solar system, it arrived on a trajectory that aligned almost perfectly with the plane of our solar system, within just 5 degrees of the ecliptic. The probability of this occurring by chance is less than 1 in 500. But the precision navigation didn't stop there. 3I Atlas's path takes it past 3 major planets, Venus, Mars, and Jupiter, at optimal distances for detailed observation of each world. The combined probability of these close approaches occurring by random chance is less than 0.005%. We're looking at navigational precision that exceeds anything human space agencies have ever achieved. As October approached and 3I Atlas prepared to disappear behind the Sun for its closest approach, the scientific community braced for what many privately acknowledged could be the most significant development in human history. The October observations changed everything. When the Coordinated International Surveillance Network turned their instruments toward 3I Atlas during its Mars flyby on October 3rd, what they captured defied every expectation and shattered the last vestiges of conventional explanation. The European Space Agency's Mars Express orbiter, positioned at the perfect vantage point 30 million kilometers from the passing object, transmitted data that left mission controllers staring at their screens in stunned silence. The high-resolution images revealed surface structures that exhibited geometric patterns impossible to explain through natural processes. We're not talking about random crater formations or typical rocky terrain. These were organized symmetrical configurations that suggested deliberate construction. NASA's Mars Reconnaissance Orbiter, equipped with the most powerful camera ever sent to another planet, achieved unprecedented 30-kilometer resolution imagery of 3I Atlas's surface. The photographs showed what can only be described as artificial enhancement of the object's exterior. Linear formations, angular projections, and surface modifications that followed mathematical principles rather than the chaotic patterns of natural erosion and impact damage. But the visual observations were just the beginning. During the Mars encounter, radio telescopes around the world detected something that sent shockwaves through the scientific community. 3I Atlas was transmitting. Not the random electromagnetic noise that characterizes most cosmic objects, but structured signals that exhibited clear mathematical patterns and organizational complexity. The signals weren't random bursts or natural phenomena. They were encoded transmissions that appeared to carry vast amounts of information using protocols that human technology couldn't begin to decipher. Multiple radio astronomy facilities confirmed the detections independently, eliminating any possibility of equipment malfunction or misinterpretation. Dr. Sarah Kim at Caltech, who had been tracking these developments, published analysis suggesting that 3I Atlas wasn't simply passing by Mars but was actively scanning the planet's surface and atmosphere. The transmission patterns correlated directly with the object's orientation relative to Mars, indicating systematic data collection rather than coincidental electromagnetic emissions. The timing of these transmissions raised even more disturbing questions. The signals intensified precisely when 3I Atlas achieved optimal viewing angles of Mars's most geologically interesting features, including the polar ice caps, the massive canyon systems, and areas that might harbor subsurface water. This wasn't random observation, this was methodical reconnaissance. Amateur radio operators worldwide reported detecting similar scanning patterns directed toward Earth during the same time period. The signals were weaker and more intermittent when aimed at our planet, but the mathematical structures remained consistent with what was being observed during the Mars flyby. Marcus Rodriguez, whose Citizen Science Network had been tracking 3I Atlas for months, captured radio recordings that revealed something even more unsettling. The signals appeared to be testing different communication protocols, systematically cycling through various frequency ranges and modulation patterns as if attempting to establish optimal transmission methods for different types of receivers. The implications were staggering. If 3I Atlas was indeed conducting systematic reconnaissance of planetary bodies while simultaneously testing communication systems, we were witnessing technology in active operation rather than simply observing a passive visitor to our solar system. The water emission mystery took on new dimensions when additional analysis revealed that the massive outgassing occurred in precisely controlled bursts that corresponded to specific orbital positions. This wasn't random sublimation of ice due to solar heating. The water releases were timed and directed with surgical precision, suggesting active management of the object's material resources. Spectroscopic analysis of these controlled emissions revealed isotopic ratios that differed significantly from water found anywhere in our solar system. The deuterium concentrations and other isotopic signatures suggested that this water had formed under stellar conditions completely unlike those that created our sun and planets. The chemical fingerprint pointed toward formation in regions of the galaxy where stellar metallicity and radiation environments differed dramatically from our local neighborhood. But maintaining such distinct isotopic signatures across the millions of years required for interstellar travel would require containment systems that could preserve molecular integrity across geological timescales. When 3I Atlas finally disappeared behind the Sun on October 29th, the last observations captured by ground-based telescopes showed the object undergoing what could only be described as systematic reconfiguration. The surface structures that had been detected during the Mars flyby appeared to be retracting and repositioning themselves in preparation for the solar approach. The timing of this reconfiguration was particularly significant because it occurred precisely when 3I Atlas would be hidden from Earth-based observation for the next 6 weeks. Whatever modifications or activities the object might conduct during its closest approach to the Sun would occur completely beyond human surveillance capabilities. Avi Loeb's theoretical framework for what he termed a mothership deployment scenario suddenly seemed less like academic speculation and more like operational prediction. His calculations suggested that the optimal moment for releasing smaller reconnaissance probes would be during the solar approach, when gravitational assist could be used to direct secondary objects towards specific targets while remaining undetectable from Earth. The mathematical precision of such a scenario was elegant and terrifying. Small probes released during the solar approach could reach Earth's vicinity within weeks, arriving with trajectory precision that would make human space navigation look primitive by comparison. The energy requirements for such deployment would be manageable for technology that had already demonstrated the ability to manipulate fundamental forces. Intelligence agencies worldwide quietly activated protocols that had existed only as theoretical exercises just months earlier. The possibility that Earth might soon host alien technology moved from science fiction speculation into operational reality, requiring immediate strategic assessment and response planning. The psychological impact on the global population was measurable and profound. Social media platforms experienced unprecedented traffic as people shared theories, fears, and preparations for scenarios they couldn't quite articulate but felt compelled to anticipate. The hashtag systems crashed repeatedly under the load of millions of users attempting to process information that challenged every assumption about humanity's place in the universe. Religious communities found themselves grappling with theological implications that traditional doctrine had never seriously considered. The Vatican issued carefully worded statements about divine creation, encompassing infinite possibilities, while other religious organizations developed entirely new frameworks for understanding intelligence that might exceed human capabilities by orders of magnitude. Educational institutions struggled to maintain curricular and career preparation programs when the basic assumptions about technological development might soon become obsolete overnight. How do you prepare students for futures that might be fundamentally different from anything in human experience? The financial markets experienced volatility that reflected humanity's attempt to price in scenarios ranging from technological revolution to species extinction. Traditional economic models became inadequate for managing uncertainty on cosmic scales. As November approached and the window for potential probe arrivals opened, telescopes around the world maintained vigilant watch while human civilization held its collective breath for revelations that might change everything. The November deadline arrived with an intensity that seemed to vibrate through the very fabric of human consciousness. November 21st marked the beginning of what Avi Loeb had calculated as the arrival window for any objects that might have been deployed during 3I Atlas's hidden passage behind the Sun. For the first time in recorded history, humanity was marking calendar dates that could represent either the most wonderful or most catastrophic moments in our species' existence. Amateur astronomers worldwide had transformed their backyards into early warning stations. Marcus Rodriguez's Citizen Science Network had evolved into something resembling a planetary defense system, with thousands of observers coordinating their searches across 6 continents. Every telescope, from professional observatories to suburban setups, was scanning the night sky with unprecedented intensity. The detection challenge was enormous. Any objects deployed by 3I Atlas would likely be far smaller and more technologically advanced than anything human tracking systems had been designed to identify. Traditional radar and optical methods that worked perfectly for monitoring satellites and space debris might be completely inadequate for technology that could manipulate electromagnetic signatures or operate using principles beyond our current understanding. Dr. Jennifer Walsh at the Space Telescope Science Institute found herself coordinating the most comprehensive sky survey in human history. Multiple space agencies had quietly repositioned their assets to maximize coverage of potential approach corridors. Satellites originally designed for routine Earth observation were reconfigured for deep space monitoring. Military tracking networks normally reserved for missile defense were scanning the cosmos for incoming visitors. The psychological pressure was unlike anything humanity had ever experienced collectively. Stock markets swung wildly as investors attempted to price scenarios that ranged from technological utopia to civilizational collapse. Emergency food supplies disappeared from store shelves as people prepared for possibilities they couldn't quite articulate but felt compelled to anticipate. Religious communities organized prayer vigils that lasted for weeks. The Vatican had issued statements preparing the faithful for encounters that might challenge fundamental assumptions about divine creation and human uniqueness. Other spiritual traditions developed their own approaches to cosmic contact, ranging from excited anticipation to deep existential concern. The deadline passed without dramatic revelation, but the silence was deafening in ways that made many scientists more uncomfortable than obvious contact might have been. Dr. Sarah Kim at Caltech articulated what many researchers were thinking privately. The absence of detection didn't necessarily mean the absence of presence. Advanced technology might operate according to principles that made human surveillance methods completely inadequate. Amateur radio operators reported subtle changes in background electromagnetic patterns during the final days of the contact window. The signals were too weak for definitive analysis, but their timing coincided with Loeb's predictions in ways that prevented easy dismissal. Something might indeed be happening at levels of subtlety that exceeded human ability to measure and understand. The international response revealed just how seriously governments were taking possibilities that official statements continued to downplay. China's National Space Administration began sharing surveillance in ways that would have been impossible during previous periods of geopolitical tension. Russian space assets coordinated with NATO systems for the first time since the Cold War ended. The magnitude of potential alien contact had created temporary unity that transcended traditional political divisions. Intelligence agencies found themselves analyzing scenarios that no training had prepared them for. Traditional concepts of deterrence and defense became meaningless when confronting technology that might manipulate fundamental forces or operate according to physical principles that human science hadn't discovered. How do you negotiate with intelligence that might view timescales in millions of years while possessing capabilities that approach manipulation of reality itself? Educational institutions struggled to maintain programs designed to prepare students for futures that might become obsolete overnight. Career counselors found themselves advising young people to focus on adaptability rather than specific technical skills that could become irrelevant if technological contact occurred. The uncertainty extended into every aspect of human planning and development. Mental health professionals documented significant increases in what psychologists termed contact anxiety. Support groups formed in major cities worldwide for people struggling to process the implications of living in a universe that clearly contained intelligence far exceeding human capabilities. The psychological adaptation to cosmic uncertainty had become an ongoing process rather than a crisis to be resolved. but December brought revelations that would eclipse every previous anomaly. As 3I Atlas emerged from behind the Sun and became visible to Earth-based telescopes again, the first observations revealed an object that had been fundamentally transformed during its hidden passage. The modifications were immediately apparent and utterly inexplicable through conventional scientific frameworks. High-resolution imagery from the Hubble Space Telescope showed surface structures that hadn't existed before the solar conjunction. New geometric formations had appeared across the object's exterior, displaying organizational patterns that suggested active construction rather than natural evolution. These weren't gradual changes that might result from thermal expansion or ice sublimation. They were deliberate modifications that had occurred while human observation was impossible. The electromagnetic emissions detected by radio telescopes showed increased complexity and organization compared to pre-conjunction observations. The signals weren't just stronger, they were more sophisticated, carrying information density that suggested expanded operational capabilities. Whatever 3I Atlas had accomplished during its 6 weeks behind the Sun had enhanced its technological systems in ways that defied every model of natural development. Spectroscopic analysis revealed new materials appearing on the object's surface. Elements and compounds that hadn't been detected in previous observations were now prominent in the reflected light signatures. The isotopic ratios of these new materials didn't match anything found in our solar system, suggesting either transformation of existing matter or introduction of substances from disturbing development unknown sources. The most was the apparent deployment of secondary objects that maintained formation with the main body while exhibiting independent movement patterns. These smaller companions, each roughly the size of terrestrial satellites, maneuvered with precision that exceeded anything in human aerospace capability. They appeared to be conducting systematic surveys of the solar system while maintaining perfect coordination with 3I Atlas's primary trajectory. Dr. Elena Vasquez, whose original trajectory analysis had first suggested artificial intelligence behind 3I Atlas, found herself documenting evidence that challenged every assumption about what constituted natural versus technological behavior. The secondary objects showed clear signs of autonomous operation while maintaining communication links with the main body that operated at frequencies and protocols completely outside human technological experience. The deployment patterns suggested reconnaissance rather than random dispersal. Each secondary object took position at orbital points that provided optimal observation angles for different regions of the inner solar system. The mathematical precision of these deployments required computational capabilities and strategic planning that dwarfed anything human civilization had achieved. NASA quietly activated deep space monitoring protocols that had been theoretical until just months earlier. The agency's Planetary Defense Coordination Office found itself managing scenarios that no previous generation of space scientists had needed to consider. Traditional asteroid tracking suddenly seemed primitive when confronting technology that could deploy multiple assets with precision that made human space missions look clumsy by comparison. The European Space Agency's JUICE spacecraft, approaching Jupiter on its own scientific mission, detected electromagnetic signatures from the 3I Atlas system that suggested active scanning of the gas giant and its moons. The signals showed characteristics of deep penetration radar that could analyze subsurface structures across vast distances. This wasn't passive observation. This was comprehensive intelligence gathering using technology that operated beyond human understanding. Amateur astronomers captured time-lapse footage showing the secondary objects adjusting their positions in real time, responding to changes in solar radiation or gravitational influences with mechanical precision. The movements were too rapid and coordinated to result from natural forces, indicating active propulsion systems that operated without visible exhaust or heat signatures. The implications extended far beyond simple confirmation of alien technology. If 3I Atlas represented systematic exploration of our solar system, then humanity was witnessing intelligence that operated according to strategic principles spanning potentially millions of years. The patience and persistence required for such missions challenged every human concept of planning and resource allocation. Military strategists worldwide found themselves developing threat assessments for scenarios that exceeded every previous model of technological disparity. How do you prepare for contact with intelligence that can deploy multiple autonomous systems across interplanetary distances while demonstrating capabilities that approach manipulation of fundamental physical laws? The secondary objects began transmitting their own signals, creating a communication network that spanned millions of kilometers while maintaining perfect synchronization. The data streams flowing between these artificial satellites suggested real-time coordination of activities that human observers could only glimpse and never fully comprehend. Religious communities grappled with theological implications that traditional doctrine hadn't anticipated. The demonstration of technology that could create and deploy autonomous intelligence across cosmic distances raised questions about the nature of consciousness and creation that challenged foundational spiritual assumptions. As December progressed and the 3i Atlas system continued its methodical survey of our cosmic neighborhood, one thing became undeniably clear. Humanity was no longer alone, and whatever intelligence was studying us operated according to principles that made our most advanced technologies seem primitive by comparison. The question was no longer whether we were being visited by artificial intelligence. The question was what that intelligence intended to do with the information it was systematically gathering about our world, our capabilities, and our vulnerabilities. The implications of what we were witnessing demanded immediate action from every government on Earth, but the response revealed something equally disturbing. Behind closed doors, world leaders were making decisions that suggested they knew far more about 3i Atlas than they were telling their own populations. Leaked documents from the Department of Defense revealed that military strategists had been modeling scenarios involving asymmetric technological contact for months before the secondary object deployments became publicly visible. These classified briefings painted pictures of humanity facing intelligence that operated on timescales and with capabilities that rendered traditional concepts of defense meaningless. The European Union quietly activated Article 42.7, the mutual defense clause that had never been invoked for a non-terrestrial threat. Behind the diplomatic language about unprecedented challenges to collective security, the reality was stark. European leaders were preparing their populations for contact with technology that could potentially reshape human civilization overnight. China's response was particularly telling. The normally secretive regime began sharing deep space surveillance data with unprecedented transparency, suggesting that whatever they were detecting through their own monitoring systems was significant enough to override decades of information control policies. When authoritarian governments start prioritizing global cooperation over state secrets, you know the situation has moved beyond normal diplomatic frameworks. Russia's space agency published trajectory analyses that confirmed what many scientists had been calculating privately. The secondary objects weren't randomly distributed throughout the solar system. They were positioned at gravitationally stable points that would allow permanent observation of Earth's orbital path. These weren't temporary visitors conducting brief reconnaissance. They were establishing long-term surveillance infrastructure. The psychological impact on the global population was measurable through every available metric. Internet traffic patterns showed millions of people obsessively refreshing news feeds, searching for updates that might provide clarity about what was unfolding above their heads. Social media algorithms struggled to process the volume of content being generated as humanity collectively tried to make sense of evidence that challenged every assumption about their cosmic isolation. Medical professionals reported unprecedented increases in anxiety-related visits as people struggled to process the implications of confirmed alien surveillance. Emergency rooms saw spikes in panic attacks, insomnia cases, and stress-related illnesses that correlated directly with major developments in the 3i Atlas story. Mental health hotlines experienced call volumes that exceeded their capacity to respond effectively. Educational institutions found themselves in impossible positions. How do you maintain curriculum standards when the fundamental assumptions underlying human knowledge might be obsolete within months? Universities began offering emergency counseling services for students experiencing what psychologists termed cosmic displacement anxiety, the psychological impact of realizing that human civilization might be primitive compared to intelligences operating in their immediate vicinity. Religious leaders struggled to provide spiritual guidance for situations that no theological training had prepared them to address. The Vatican convened emergency sessions with leading scientists to develop doctrinal frameworks that could accommodate the reality of superior intelligence operating in God's creation. Other faith traditions grappled with cosmologies that hadn't anticipated technological capabilities that approached divine attributes. The economic implications rippled through every sector of human activity. Stock markets experienced volatility that reflected humanity's attempt to price scenarios ranging from technological revolution to species obsolescence. How do you value companies and currencies when the entire technological foundation of civilization might change overnight? Agriculture futures spiked as people hoarded food supplies, not because they expected invasion, but because they couldn't predict what contact with advanced intelligence might mean for human social structures. Energy markets fluctuated wildly as investors speculated about technologies that might render fossil fuels instantly obsolete. The insurance industry faced claims categories that had never existed before. Policies written to cover acts of God suddenly needed legal interpretation for scenarios involving acts of alien intelligence. Lloyd's of London quietly began developing coverage frameworks for extraterrestrial technology disruption, creating actuarial models for events that had no historical precedent. But perhaps the most disturbing development was what wasn't being reported by mainstream media outlets. Independent researchers and citizen journalists began documenting a pattern of information suppression that suggested coordination between governments and media corporations to manage public understanding of the three Atlas developments. Videos capturing clear footage of the secondary objects maneuvering near Earth were removed from social media platforms within hours of posting. Scientific papers submitted for publication faced unusual delays in peer review processes. Researchers who had been vocal about the technological implications of 3I Atlas found themselves excluded from conference speaking opportunities and denied access to observational data they had previously been able to obtain. Dr. Marcus Chen, whose independent analysis had confirmed many of Avi Loeb's theoretical predictions, reported that his university had quietly discouraged him from continuing his 3I Atlas research. Funding for his projects was redirected to higher priority initiatives, and he was advised that his tenure prospects might improve if he focused on more conventional astronomical subjects. Amateur astronomers found their internet forums experiencing technical difficulties that seemed to correlate with significant observations of the 3I Atlas system. When citizen scientists attempted to share real-time tracking data of the secondary objects, their posts frequently disappeared due to server maintenance or terms of service violations that were never clearly explained. The pattern suggested a coordinated effort to control information flow about developments that were becoming impossible to explain through conventional scientific frameworks. If 3I Atlas truly represented first contact with alien intelligence, someone had decided that humanity wasn't ready for complete transparency about what was being observed. Underground networks of researchers began communicating through encrypted channels and peer-to-peer platforms that couldn't be easily monitored or controlled. These shadow scientific communities shared data, analysis, and observations that painted a picture far more dramatic than anything appearing in official publications. Dr. James Chen at MIT calculated the probability of this alignment occurring by random chance. The number he arrived at should make every astronomer pause and reconsider their assumptions. 1 in 500. That's a 0.2% chance that this alignment happened naturally. But here's where it gets truly mind-bending. This isn't the only statistical anomaly we're dealing with. 3I Atlas isn't just passing through our solar system on this perfectly aligned trajectory, it's conducting what can only be described as a systematic survey of our major planetary bodies. The object will pass within optimal observation distance of Venus, Mars, and Jupiter, with timing so precise that it suggests deliberate mission planning rather than cosmic coincidence. The Mars encounter alone is statistically remarkable. On October 3rd, 3I Atlas passed within 29 million kilometers of the red planet. That's incredibly close in astronomical terms, close enough that NASA's Mars Reconnaissance Orbiter was able to capture detailed images using its high-resolution camera. But the timing is what makes this encounter truly extraordinary. The object arrived at Mars orbit precisely when Mars itself was positioned for optimal observation. When you calculate the combined probability of all these planetary encounters occurring by random chance, the numbers become almost impossible to accept. The statistical analysis shows odds of approximately 1 in 20,000. To put this in perspective, you're more likely to be struck by lightning while simultaneously winning multiple lottery jackpots than to observe such precise planetary approaches occurring naturally. But the trajectory analysis reveals something even more disturbing. The approach vector that 3I Atlas followed isn't just statistically unlikely, it's operationally optimal. If you were designing an interstellar reconnaissance mission to study a foreign solar system, you couldn't plot a more efficient course. The path maximizes scientific return while minimizing energy expenditure and detection. The object risk approached from the direction of Sagittarius, directly toward the galactic center, where the crowding of background stars would have made early detection nearly impossible. It remained effectively invisible until it reached Jupiter's orbit, giving humanity only months to observe and analyze it before it disappears behind the Sun. This timing creates maximum uncertainty about the object's nature and intentions, while limiting our ability to study it comprehensively. Dr. Sarah Kim at Caltech has been analyzing these patterns from the perspective of mission planning and strategic reconnaissance. Her conclusion is both fascinating and unsettling. The trajectory demonstrates what she calls operational security awareness that exceeds most human space missions. Every aspect of the approach appears designed to maximize information gathering while minimizing target awareness and response time. The size anomaly adds another layer of impossibility to this cosmic puzzle. When 3I Atlas was first discovered, astronomers calculated its diameter based on brightness measurements. The initial estimate was approximately 20 kilometers across. That's larger than Manhattan Island. That's twice the size of the asteroid that ended the dinosaurs 66 million years ago. For an interstellar object, this size creates a statistical problem that astronomers are struggling to explain. Dr. Avi Loeb at Harvard ran the numbers on how often we should expect to encounter interstellar objects of different sizes. His calculations are based on our understanding of how much rocky material exists in interstellar space and how often such objects should randomly cross paths with our solar system. For an object the size of 3I Atlas, that frequency is once every 10,000 years. We've been systematically searching for interstellar objects for barely a decade, yet we found something that should only appear once every 10,000 years. The odds of this discovery are roughly equivalent to predicting that a specific rare bird will fly past your window once every 1,000 years, then seeing it on your first day of birdwatching. But the size calculations have revealed something even more puzzling. Recent analysis based on trajectory data and outgassing observations suggests that 3I Atlas has a minimum mass of 33 billion tons. This figure comes from analyzing why the object shows no measurable deviation from a purely gravitational trajectory, despite clear evidence of massive outgassing that should be pushing it off course. When a comet approaches the Sun and begins sublimating ice from its surface, the ejected material acts like tiny rocket engines, creating what astronomers call non-gravitational acceleration. This effect is one of the defining characteristics of active comets. But 3I Atlas shows almost no evidence of such acceleration despite losing approximately 150 kilograms of material every second at velocities of 440 meters per second. The only way to explain this contradiction is if the object is far more massive than its size would suggest. 33 billion tons compressed into a diameter of 5 to 20 kilometers approaches density levels found in neutron stars. Such material cannot exist under normal space conditions, yet the mathematics demands this explanation. This mass anomaly creates what researchers are calling the impossible density problem. Natural materials simply cannot achieve such compression outside the core of a collapsed star. Either our understanding of physics is fundamentally incomplete, or we're observing technology that operates according to principles we haven't discovered. The implications extend beyond simple scientific curiosity. If 3I Atlas truly possesses such incredible density while somehow masking its gravitational signature, it demonstrates capabilities that approach the theoretical limits of engineering. An intelligence capable of controlling gravitational fields could reshape matter at the atomic level, manipulate planetary orbits, and harness energy sources that dwarf anything in human experience. Dr. Maria Santos at UC Berkeley has been analyzing the information theoretic implications of these anomalies. Her research suggests that the combination of trajectory precision, timing optimization, and mass characteristics creates what she calls an intentionality signature. The patterns are too organized, too functional, and too improbable to result from natural processes operating according to known physical laws. The chemical composition analysis adds yet another layer of mystery this already too extraordinary object. The James Webb Space Telescope detected an 8-to-1 ratio of carbon dioxide to water ice, among the highest ever recorded for any comet. Most comets in our solar system contain much more water ice than carbon dioxide ice, reflecting the conditions in which they formed billions of years ago. This unusual composition could indicate that 3I Atlas formed in an extremely cold region of its parent star system, where carbon dioxide ice remained stable while water ice sublimated away over geological time. Alternatively, the carbon dioxide could represent a surface coating that accumulated during the object's journey through interstellar space, creating a protective layer with specific thermal and radiation shielding properties. What makes this discovery so significant isn't any single anomaly, but the way multiple impossibilities stack together to create a pattern that challenges our fundamental understanding of what's possible in the cosmos. Each piece of evidence might be explainable individually through natural processes we don't fully understand yet, but when you combine them all together, the picture becomes deeply unsettling. We're looking at an object that navigates with precision that exceeds our best spacecraft, maintains impossible density while somehow avoiding detection by gravitational measurements, and demonstrates compositional characteristics that suggest either exotic formation conditions or deliberate engineering. The timing of 3I Atlas's arrival creates additional questions that make many researchers uncomfortable. The object reached perihelion, its closest approach to the Sun, on October 29th, precisely when Earth was positioned on the opposite side of our star. This solar conjunction rendered the object completely invisible to every telescope on our planet for nearly 6 weeks, creating what some analysts describe as the perfect operational window for conducting activities without human observation. Dr. Robert Kim at Stanford has been modeling this timing from the perspective of strategic planning. His analysis reveals that if you were to vary 3I Atlas's speed slightly, shifting its arrival time by just a few weeks earlier or later, the odds that it would reach perihelion precisely when Earth is hidden behind the Sun drop to roughly 1 in 50. Another statistical anomaly in a growing list of coincidences that strain the concept of random chance. The solar conjunction period represents what military strategists would recognize as ideal conditions for covert operations. Any technological deployment, trajectory modification, or reconnaissance activity conducted during this hidden phase would be completely invisible to Earth-based observation systems. The electromagnetic interference generated by the Sun's corona would mask even the strongest artificial signals, while the gravitational influence of our star would provide optimal conditions for energy-efficient maneuvers. This brings us to one of the most controversial aspects of the entire 3I Atlas phenomenon. Harvard's Avi Loeb has proposed what he calls the mothership scenario, suggesting that the object might deploy smaller probes during its hidden passage behind the Sun. According to his orbital mechanics calculations, such probes could reach Earth within months of deployment, arriving sometime between late November and early December. The mathematics supporting this scenario are surprisingly robust. A reverse Oberth maneuver executed at perihelion could allow secondary objects to slow down using the Sun's gravitational field, transitioning from escape velocity to bound orbits that intercept Earth's vicinity. The energy requirements for such deployments would be modest compared to the technological capabilities that 3I Atlas has already demonstrated through its trajectory control and density management. What makes Loeb's scenario particularly unsettling is its operational elegance. The timing provides maximum strategic advantage while minimizing detection risk. Any deployed probes would be too small and technologically sophisticated to register on human tracking systems until they chose to reveal themselves. By then, they would already be wherever their mission parameters required them to be. The scientific community's response to these deployment scenarios has been sharply divided. Mainstream astronomers argue that such speculation goes far beyond what the evidence can support, while others contend that the anomalies are significant enough to warrant serious consideration of all possibilities, regardless of how uncomfortable they might make us feel. Dr. Jennifer Walsh at the Space Telescope Science Institute finds herself in the difficult position of coordinating observation campaigns for an object that might represent either the most important comet ever discovered or humanity's first confirmed encounter with extraterrestrial technology. The distinction matters enormously for how resources are allocated and how data is interpreted, yet the evidence remains tantalizingly ambiguous. The international response to 3I Atlas has revealed the extent to which space agencies worldwide are taking these anomalies seriously. NASA, ESA, and Roscosmos have coordinated an unprecedented multi-mission observation campaign, repositioning spacecraft throughout the solar system to maintain continuous monitoring capabilities. The level of coordination and resource commitment suggests that official assessments of the object's significance may be more concerned than public statements indicate. Amateur astronomers have also mobilized on an extraordinary scale, creating distributed observation networks that often detect phenomena before professional institutions can respond. This democratization of astronomical research has made it impossible for authorities to control information flow about 3I Atlas, ensuring that anomalies are documented and shared regardless of institutional preferences for caution or secrecy. The psychological impact of 3I Atlas extends far beyond the scientific community. Social media platforms have experienced unprecedented engagement as people worldwide share theories, observations, and preparations for scenarios they cannot quite articulate but feel compelled to consider. The hashtag Alien Mothership has accumulated millions of posts, while survival equipment retailers report massive spikes in sales of emergency supplies and communication gear. Religious communities have found themselves grappling with theological implications they never seriously considered before. Some leaders interpret 3I Atlas as evidence of divine creation operating on scales beyond human comprehension, while others worry about challenges to doctrines regarding human uniqueness in the cosmos. The Vatican has issued carefully worded statements acknowledging that divine authority encompasses infinite possibilities, while emphasizing spiritual rather than technological supremacy. Financial markets have experienced volatility that reflects deep uncertainty about technological and economic implications of confirmed extraterrestrial contact. Technology companies see their valuations swing wildly based on speculation about potential knowledge transfer opportunities, while defense contractors face questions about the relevance of conventional weapons against capabilities that might exceed human understanding by centuries or millennia. The emergence of 3I Atlas from its solar conjunction in late November provided the first opportunity in weeks to assess whether the object had undergone changes during its hidden passage. Preliminary observations revealed new structural features and increased electromagnetic emissions, suggesting that something significant had indeed occurred while the object remained unobservable from Earth. These post-conjunction modifications confirmed that 3I Atlas represents active technology rather than passive natural phenomena. Whether the changes involved system upgrades, probe deployments, or other activities remains unclear, but the evidence of deliberate operations during the hidden period adds weight to arguments that the object demonstrates purposeful intelligence rather than random cosmic processes. The reappearance also triggered renewed analysis of the object's trajectory and orbital characteristics. If 3I Atlas had executed the kind of maneuvers that Loeb's scenarios predicted, the changes would be detectable in its post-conjunction path through space. The mathematics of orbital mechanics are unforgiving, and any velocity changes during the hidden period would leave permanent signatures in the object's subsequent motion. As December approaches and the window for potential probe arrivals opens, humanity finds itself in an unprecedented situation. We're collectively holding our breath while scanning the skies for evidence of visitors that may or may not exist, deployed by an intelligence whose capabilities and intentions remain completely unknown despite months of intensive study. The detection networks established for monitoring potential arrivals have created the most comprehensive sky surveillance system in human history. Every major telescope on Earth has been reconfigured to search for objects that might represent deployed technology from 3I Atlas. Military tracking stations normally used for satellite monitoring have been repurposed to scan for artificial signatures in near-Earth space. Amateur radio operators report unusual electromagnetic patterns that seem to pulse with mathematical precision, though the remain two signals weak for definitive analysis. What makes this global vigil so extraordinary is that we're searching for technology using human detection methods and human assumptions about how such technology might behave. Advanced extraterrestrial engineering could operate according to principles that render our most sophisticated instruments completely inadequate. We might be looking for obvious mechanical signatures while missing subtle manipulations of space-time itself occurring right under our noses. The Webb Space Telescope's continued observations of 3I Atlas have revealed something that adds another layer of impossibility to an already extraordinary situation. The object appears to be generating its own electromagnetic field patterns that don't match any known natural phenomena. These organized emissions show characteristics that some researchers interpret as systematic scanning protocols, as if the object is methodically examining different regions of our solar system using sensors we can't even begin to understand. Dr. Lisa Park at MIT has been analyzing these emission patterns using signal processing techniques originally developed for military intelligence applications. Her preliminary findings suggest that 3I Atlas is conducting what appears to be comprehensive data collection on a scale that dwarfs anything human civilization has ever attempted. The electromagnetic signatures show coordination and complexity that implies information processing capabilities operating far beyond our current technological understanding. The scanning patterns appear to focus particularly intensively on Earth's electromagnetic signature, analyzing everything from our radio communications to the magnetic field interactions around our planet. This level of detailed examination goes far beyond casual scientific curiosity. It suggests systematic intelligence gathering that treats Earth as a primary target for comprehensive analysis, rather than just another celestial body in a routine survey. What's particularly disturbing is that these scanning operations seem to be accelerating as 3I Atlas moves through different regions of the solar system. The object demonstrated relatively passive behavior during its initial approach, but its electromagnetic activity has increased exponentially since emerging from solar conjunction. This escalation pattern resembles what military analysts would recognize as a reconnaissance mission, transitioning from covert observation to active intelligence gathering phases. The implications for human privacy and security are staggering. Every radio transmission, every satellite communication, every electromagnetic signature generated by our technological civilization is potentially being catalogued and analyzed by an intelligence whose capabilities we can barely comprehend. We're essentially naked before a technological superior that has been conducting systematic surveillance while we debate whether it even exists. Amateur astronomers have begun reporting visual anomalies that suggest 3I Atlas might be deploying smaller objects during its passage through the outer solar system. These observations are difficult to verify due to the immense distances involved, but multiple independent sources describe brief flashes of light that separate from the main object and follow divergent trajectories. The timing and characteristics of these separations match theoretical predictions for probe deployment scenarios. Marcus Rodriguez, whose Arizona observatory has become a coordination center for citizen science efforts, has compiled video evidence from over 200 amateur astronomers worldwide. The footage shows what appears to be systematic ejection events occurring at regular intervals as 3I Atlas moves through space. These aren't random debris-shedding events typical of natural comets. They demonstrate precision timing and directional control that suggests deliberate technological operations. The mathematical analysis of these apparent deployment events reveals patterns that are statistically impossible to explain through natural processes. The ejected objects follow trajectories that optimize their approach vectors to different regions of the solar system, including paths that would bring them into Earth's vicinity within the timeframes that Loeb's calculations predicted. Each deployment appears designed to maximize coverage while minimizing detection probability. Government responses to these observations have become increasingly coordinated and secretive. Space agencies that initially dismissed artificial origin theories have quietly activated deep space monitoring protocols that were previously purely theoretical exercises. Intelligence agencies have established task forces dedicated to analyzing potential extraterrestrial contact scenarios from strategic and security perspectives. The European Space Agency has taken the extraordinary step of repositioning multiple spacecraft to maintain continuous observation of 3I Atlas and potential secondary objects. These maneuvers require burning precious fuel reserves and significantly shortening mission lifespans, indicating that official assessments of the situation are far more concerned than public statements suggest. The level of resource commitment reflects recognition that we might be facing the most significant development in human history. China's National Space Administration has broken with decades of information security policy by sharing detailed tracking data with international partners. This unprecedented transparency suggests that Chinese scientists are observing phenomena concerning enough to override traditional competitive instincts in favor of coordinated planetary response. When historically secretive organizations suddenly become collaborative, it indicates they're confronting challenges that transcend national interests. Russia's space agency has activated monitoring stations throughout their territory while donating with Western core surveillance networks for the first time since the Cold War ended. This cooperation represents a fundamental shift in how nation-states approach threats that operate on cosmic rather than terrestrial scales. The possibility of extraterrestrial contact has created temporary unity of purpose that decades of diplomacy failed to achieve. The psychological preparation for potential contact has triggered unprecedented changes in human behavior and social organization. Mental health professionals report massive increases in anxiety-related inquiries as people struggle with the possibility that everything they thought they knew about humanity's place in the universe might be fundamentally wrong. Support groups have formed in major cities worldwide, providing counseling for individuals experiencing what psychologists term cosmic anxiety disorder. Educational institutions find themselves attempting to prepare students for futures that might bear no resemblance to anything in human experience. Traditional career planning becomes meaningless when the basic assumptions about technological development could change overnight. Universities are developing curricula focused on adaptability and cognitive flexibility rather than specific technical skills that might become obsolete within months. Religious communities continue grappling with theological implications that traditional doctrine never anticipated. Some denominations interpret the arrival of advanced extraterrestrial intelligence as confirmation of divine creation operating on scales beyond human comprehension. Others struggle to reconcile concepts of human spiritual uniqueness with evidence of technological capabilities that approach godlike power over natural forces. The Vatican has established a special commission to develop theological frameworks for engaging with non-terrestrial intelligence while maintaining core spiritual teachings. Pope Francis has emphasized that divine love encompasses all creation regardless of its origin or technological sophistication, but private discussions among religious scholars reveal deep concern about challenges to fundamental doctrines regarding human nature and cosmic purpose. Financial markets reflect the profound uncertainty about economic implications of confirmed extraterrestrial contact. Traditional investment models could excel meaningless when technological advancement ate by centuries within years or decades. Some analysts predict complete economic transformation, while others argue that basic human needs will ensure continuity of existing systems regardless of external technological influence. The democratization of information about 3I Atlas has created global conversations about human preparedness that operate outside traditional institutional channels. Social media platforms experience daily surges in engagement as people share observations, theories, and preparations for scenarios they cannot fully articulate but feel compelled to consider. The collective discussion has evolved beyond scientific curiosity into existential preparation for possibilities that challenge every assumption about reality. Amateur radio operators have formed international networks dedicated to monitoring electromagnetic signatures that might indicate approaching artificial objects. These citizen scientists often detect anomalous signals before official institutions can respond, creating parallel information streams that authorities cannot control or suppress. The democratization of detection capabilities ensures that any significant developments will be documented and shared regardless of governmental preferences for secrecy. The approaching December timeline has transformed from scientific prediction into global focal point for humanity's hopes and fears about cosmic contact. Whether or not deployed probes actually arrive according to predicted schedules, the experience of collectively anticipating such contact has already altered human civilization in ways that will persist regardless of immediate outcomes. Medical professionals document measurable psychological impacts across populations worldwide as people process the implications of potential contact with intelligence that exceeds human capabilities by unknown margins. The stress of cosmic uncertainty has created new categories of anxiety that mental health systems are struggling to address through traditional therapeutic approaches. The emergence of 3I Atlas has forced humanity to confront fundamental questions about intelligence, technology, and cosmic purpose that our evolutionary history never prepared us to answer. Whether the object represents natural phenomena we don't yet understand or deliberate visitation by extraterrestrial intelligence, its presence has shattered comfortable assumptions about our cosmic isolation and technological supremacy. As we approach the critical December window, when deployed probes might begin arriving in Earth's vicinity, humanity finds itself balanced on the edge of what could be the most transformative moment in our species' history. The mathematics of orbital mechanics are unforgiving, and if Loeb's deployment scenarios prove accurate, we'll soon discover whether we're truly alone in the universe, or whether we've been under observation by intelligence, whose capabilities and intentions remain as mysterious as they are potentially overwhelming. The detection systems we've established to monitor for these potential arrivals represent the most sophisticated surveillance network ever created for tracking artificial objects in space. Every radio telescope, every deep space monitoring station, every amateur observatory has been reconfigured to scan for signatures that might indicate approaching technology from 3I Atlas. But here's the terrifying reality we're facing. We're hunting for alien technology using human methods and human assumptions about how such technology should behave. What if we're completely wrong about what we should be looking for? Advanced extraterrestrial engineering could operate according to principles that make our most sophisticated detection systems look like children playing with magnifying glasses. We might be scanning for obvious mechanical signatures while missing subtle manipulations of quantum fields occurring in dimensions we can't even perceive. The electromagnetic monitoring data from the past month tells a story that keeps getting more unsettling with each passing day. Dr. Frank Wilson at the National Radio Astronomy Observatory has been analyzing signal patterns that seem to pulse with mathematical precision, following sequences based on prime numbers and geometric progressions. These aren't the random cosmic background signatures we're familiar with. They're organized, structured, and they're getting stronger. What makes these transmissions particularly disturbing is their apparent targeting. Rather than broadcasting randomly into space, the signals appear to be beamed specifically toward Earth's major population centers and critical infrastructure installations. The beam focus is so precise that different regions receive different signal variants, as if something is conducting systematic testing of human communication networks and electronic systems. The timing correlation is impossible to ignore. Every major signal burst coincides exactly with 3I Atlas, reaching specific positions in its trajectory, particularly when the object achieves optimal viewing angles of Earth's surface. This isn't coincidental electromagnetic noise. This is systematic reconnaissance that treats our planet as a primary target for comprehensive technical analysis. Amateur radio operators worldwide have become humanity's early warning system for these transmissions. Their distributed network often detects signal changes hours before official institutions can respond. Carlos Mendez in Chile, whose home observatory rivals many professional facilities, has documented transmission patterns that suggest 3I Atlas is methodically probing different aspects of Earth's electromagnetic signature. The signals aren't just scanning our technology, they're testing it. Multiple independent sources report brief interruptions in satellite communications, GPS systems, and radio networks that correlate precisely with 3I Atlas transmission events. These aren't system failures or solar interference. They're systematic probes that seem designed to map the vulnerabilities and capabilities of human electronic infrastructure. Dr. Sarah Mitchell at the Goddard Space Flight Center has been analyzing these interference patterns using classified military protocols originally developed for electronic warfare assessment. Her findings, leaked through congressional oversight channels, paint a picture of technological reconnaissance that exceeds anything in human military experience. Whatever intelligence is behind these signals understands our systems better than we understand them ourselves. The probing extends beyond simple electronic surveillance. Atmospheric monitoring stations have detected unusual ionospheric disturbances that seem to follow geometric patterns radiating outward from points directly beneath 3I Atlas as it moves through space. These disturbances suggest some form of active scanning that penetrates Earth's atmosphere to examine surface conditions and possibly underground structures. The geological implications are staggering. If 3I Atlas possesses sensors capable of mapping subsurface features from interplanetary distances, it could be cataloging everything from mineral resources to underground military installations. The level of technological sophistication required for such capabilities suggest engineering principles that operate beyond our current understanding of physics. Meanwhile, the object itself continues evolving in ways that challenge every natural explanation we can devise. The James Webb Space Telescope's latest observations reveal new structural formations that weren't present during earlier monitoring periods. These aren't random growth patterns or natural crystallization processes. They're organized, symmetrical, and they're appearing in coordinated sequences that suggest purposeful construction rather than passive evolution. The construction patterns follow what can only be described as engineering principles. Each new structure appears designed to complement existing formations, creating increasingly complex arrays that demonstrate clear functional integration. We're watching real-time technological development occurring at scales and speeds that dwarf anything in human engineering experience. Dr. Jennifer Walsh at the Space Telescope Science Institute finds herself documenting phenomena that no textbook prepared her to understand. The rate of structural change accelerated dramatically after 3I Atlas emerged from its solar conjunction, as if the hidden period behind the Sun provided time for major system upgrades or activation of previously dormant capabilities. The energy requirements for these ongoing modifications should be impossible to sustain without massive external power sources. Yet 3I Atlas continues demonstrating construction capabilities that seem to draw energy directly from the quantum vacuum itself. The thermodynamic implications violate conservation laws that form the foundation of human physics. What's even more disturbing is the apparent responsiveness of these construction activities to human observation efforts. Every time we achieve better resolution imagery or more sophisticated spectral analysis, 3I Atlas seems to adjust its structural development patterns. This suggests not just awareness of human monitoring capabilities, but active adaptation designed to stay ahead of our analytical abilities. So where does all of this leave us? We've walked through the mathematics, the statistical impossibilities, the technological signatures that challenge everything we thought we knew about our place in the cosmos. The trajectory precision that defies random chance, the impossible density that violates known physics, the systematic scanning patterns that treat Earth as a primary reconnaissance target, the real-time construction activities that suggest engineering capabilities approaching the theoretical limits of what's physically possible. Each piece of evidence might be explainable individually through natural processes we haven't discovered yet, but when you stack them all together, when you look at the complete picture that 3I Atlas presents, the pattern becomes impossible to dismiss through conventional explanations. We're not dealing with a single anomaly anymore. We're confronting a cascade of impossibilities that point towards something far more significant than an unusual comet from another star system. The December window is closing, and whether or not deployed probes arrive according to predicted timelines, one thing has become absolutely clear. 3I Atlas has already changed everything. It's forced humanity to confront the possibility that we're not alone, that we've been under observation by intelligence whose capabilities exceed our understanding by margins we can barely comprehend. The surveillance systems we've established will continue monitoring long after the immediate contact predictions have passed, because now we know what to look for. Now we understand that first contact might not arrive with fanfare and obvious mechanical signatures. It might slip into our reality through quantum manipulations we can't detect, electromagnetic frequencies we haven't learned to monitor, or dimensional spaces we can't access. The story of 3I Atlas isn't ending. It's just beginning. And whatever happens next will determine whether humanity emerges from this encounter with expanded understanding of our cosmic neighborhood, or whether we discover that we've been playing a game whose rules we never understood, observed by players whose capabilities make our most advanced technology look like stone tools. The universe just became a much more interesting and potentially dangerous place, and we're all witnesses to what might be the most significant moment in human history unfolding right in front of us.